Thanks, Joachim and Tai. He called us legends. I think by definition, a legend is something very old, so I'm not sure how we should be taking that.
Or dead. So we'll strive for both. Give us a second here. Let's see, are we plugged in? There it is. Awesome. There's our title slide, and there's the title of the talk. I'm Chet Haase. I'm on the developer relations team. Recently, on the developer relations team for Android, which means I go around and do stuff like this and try to help people understand how to program Android.
And I'm Romain. I manage the toolkit team at Google, and I'm jealous of Chet. Look at that fancy title he has. He's the Chief Android Advocate.
Trick with titles at Google is you can really have any title you want. Don't tell anybody. All right, wanted to talk about a couple of things today. This is then and now. We're going to go over a little bit of history to sort of paint some context of where Android came from, and then spend a bunch of time talking about recent changes that we're doing for developers and users to make it sort of a more solid and robust and platform that we all love to use and develop for.
I think a more candid way to say that is we're going to explain why we're making your life more difficult.
Yeah, that's the subtext here. But first, let's talk about history. So back in the early days, before I was there, but when Romain was there, it was all about just trying to ship 1.0, right? So there were various steps in there. First one was writing a demo. So back in the early days, Android was basically a JavaScript program. It was a JavaScript program running on some sort of candy bar phone or also a desktop, and it was basically demonstrating what they wanted Android to be. And this was the pitch that they then gave to investors and eventually to Google that led to the acquisition. So
I mean, let that sink in for a moment. They managed to sell a company to Google by showing them a JavaScript demo of an operating system.
Google
Makes me feel very inadequate about my marketing skills.
Google loves JavaScripts. All right, so then they actually needed to build the platform. So reboot, delete all that JavaScript code and write the stuff. Make some APIs because from the beginning it was intended to be a developer platform that not just Google apps would run on, but apps from developers everywhere it would run on. Making it all work would be kind of nice, more particularly given the devices at that time, they needed to make it work on that G1 phone, right? So you think it's hard to squeeze everything into phones these days. Try, well, how big was the memory at that point? 192?
Yes, we had 64 megs for the user space.
No one will ever need more than 64. And then actually ship it, so 1.0 shipped. So let's talk about what some of these things entailed. So in building the platform, you start from a kernel. So they had the Linux kernel. They basically were able to take this thing. They did not need to build their kernel. They could just take Linux out of the box and then simply add to it what they needed to. In particular, we'll probably talk about this later, but wake locks were kind of important at the time. If you shut down your laptop or whatever Linux system you're using, then it could completely shut down. That was the point. You could retain all battery because there was nothing it needed to do.
Or worse, you would keep running and burn your battery.
Yeah. Given the state of Linux at that time, could have done that. But they needed the concept of a wake lock, which was, you know, it's kind of important for if you're in the middle of a phone call to actually keep that phone call going. So they added capability to the Linux kernel to stay awake, right? Which is really important, it's really useful. Unfortunately, it got abused as well, so we've cranked back a little bit on that in recent times. But the main thing they did at the kernel level was to add drivers. You needed the OS to actually talk to the camera hardware, to talk to the display hardware, to talk to the binder interface for the IPC mechanism going on in the OS. All right, so that's the lowest layer. On top of that, you had a couple of languages. Back in the early days, they started from JavaScript for the demo, and they thought maybe we'll actually use JavaScript for the APIs and the language that we program to the platform as well. So JavaScript was in contention also. They talked about C and C++, and they talked about having Java and maybe all of these things. And then eventually they decided, okay, the developer side of this is going to be Java programming language for all of the APIs, but a lot of the platform is also written in C++. Most of the runtime, Dalvik runtime, now Art runtime. You've got the framework codes, all of the APIs, again, at the Java level, a lot of the functionality at the Java level, but also a bunch of stuff at the native level in C and C++, UI toolkit, same thing, media, camera APIs, and on throughout the platform. And then on top of that, you have the APIs.
And speaking of APIs, so obviously the idea of APIs was to maximize functionality. So there were a lot of APIs that came with Android 1.0 that you still know and hopefully love today. Things like intents and broadcasts that were somewhat novel at the time. And in particular, Android apps did not work like typical typical applications. You didn't have a main functions to enter the app. You had like multiple entry points, and I know it was confusing to developers. But we also needed to make everything fit in those tiny phones. So it led to many API designs that we may regret today, but that made the platform possible. And the reason we're here today to complain about those decisions is that we made them back then. So a typical example is not using objects when you want to set the coordinates of a view. You don't pass a position object, the position instance. You pass integers. We also loved using bit fields. So this is an example of how things are implemented in the base view.java source file. We have a lot of state, and instead of using 1 Boolean per bit of information, because a Boolean is 8 bits, we just use 1 bit inside an integer. So we have this thing called private flags. Of course, eventually we ran out of bits into that integer, so we had private flags 2. Of course, we ran out, so we had 3.
I think I added 3. Yeah.
And we ran out again, and now we have 4. That's a lot of Booleans. That's 128 Booleans, which probably says a lot about the BSView class. I mean, it's a little wrong. And of course, everything's pretty much mutable. One of the reasons was to be able to reuse objects because the garbage collector was not efficient at all, and you could get pauses of like 150 milliseconds. What's interesting there for API design, building a platform like this is very difficult because basically nobody trusted, the Android team to be able to deliver something back then because Google had no history of building phones or even operating systems. So we had to convince a lot of people. So there were a lot of tight deadlines. So there's one thing I learned. You cannot design good APIs when you don't have time to design the APIs. So if you work on APIs, if you work on libraries, please take the time. Don't turn that into a research project, but don't rush to release because then you're going to end up with a lot of regrets.
On the other hand, it's more important to ship than to come out with a perfect API way too late, which was another option. All right, so now that we had the APIs, we could develop some apps. So internally, apps were being developed in parallel with the platform, which is kind of weird if you think about it. Like the framework and the UI toolkit were being developed as apps like Gmail were being developed on top of it, which meant that people on the Gmail team would then add APIs to the framework that they needed and then go back to Gmail and sort of go back and forth. People on the toolkit team would go work on the apps to make sure the performance was there or add new functionality and features. And so it was all sort of this internested development happening
as
at the
a
time.
UI toolkit developer, I even owned the email application for a while, which makes no sense whatsoever.
All of the core apps that we know and love, as well as the services that actually connected to the backends at Google, so you can actually get to your inbox, and so that we can push notifications to tell you when you have messages waiting for you, Talk, all of these things. Actually, Talk is interesting. That provided the single pipe that everything talked through, right? It was developed specifically for the Talk application, but it had the functionality everybody needed, which was that persistent connection to the back end. Market, we'll talk about Market in a little bit. And then, of course, it would be nice if developers could actually access these APIs as well. So all of this stuff was being developed before we released the SDK, before anybody really knew what Google was doing. So eventually, we released it to a point where external developers could participate. So here's the basic timeline. So in July of 2005, Android was acquired, and then platform development began and continues to this day. Google app development started sometime in early 2006 and also continues to this day. SDK was released in November of 2007. This was the first time when developers could actually see what was going on and write applications for it. It was a little tricky because, of course, the APIs are evolving at the time. So you're writing applications, and then the new SDK, maybe that API has changed. In the meantime, and then external app development could continue through that time to get posted to 1.0.
And then to seed market, we had this Android Developer Challenge, which was a contest for developers to build applications, and we had $10 million to distribute.
$10 million.
They were split between the first Android Developer Challenge and the second Android Developer Challenge. And almost 12 years later, we just announced the Android Developer Challenge 3, and there's $0 from that 10 million that's going to it.
Yes, still a total of 10 million, but we already spent it. So, yes. All right, and then 1.0 comes out, and the G1 is released, and now everybody can actually release their apps on market, which is fantastic, except that Google's really good at giving stuff away. Charging money for it is hard. So the first version of market, you couldn't actually make money on your app because we didn't know how to do that. So there was a later release, a couple of months later, where we figured out how to actually charge money, and then developers could make money on their applications.
All right, so to ship this 1.0, we had to cut a lot of features. Like the past few months of development were basically, our boss coming into the office every morning saying, okay, so today we are dropping, feature foo and feature bar. It was a little painful, but that's how we ship. So we spent many, many years after that just catching up to all the things we wanted to build, we didn't have time to build. So some of them were very foundational, some of them were more extra features for the users. The first big one was the NDK. So the NDK, I don't know, how many people use the NDK here? Okay, actually more than I thought. And the NDK was mainly created to be able to port games to Android, because games tend to be cross-platform and they tend to be written in native languages. But the goal was never to make all the platform APIs available through the NDK. We keep adding new APIs as time goes on, but the idea was never to let you write an entire app strictly from NDK with the same UI toolkit, for instance. We added support for multiple densities, soft keyboard, turn-by-turn navigation. We gave an entire talk on that. Flash support was added, if you remember
was
Flash.
Huge. So I was at Adobe at the time, and I think we called it the real web. I'm not sure. There was some sort of marketing slogan that was used for Flash, and it kind of was at the time. Like, you really needed plugin environments like Flash to have real interactive capabilities. But in parallel, HTML5 was coming online, which created more capabilities for developers eventually, where you didn't need plugins.
Yeah. Then we did tablets. For tablets, we had to introduce hardware acceleration for drawing. Then Holo, which was our first redesign of the UI, which led to Material Design later on.
Then there was another important development in Flash. We got rid of it. It was no longer the real web. It was the old web.
Then Project Butter, focusing on optimization. So that's basically where we were kind of done with like the very foundational things we need to build to have a strong operating system, and we could focus on more polish. Butter, then right to left support, Svelte, which was about optimizing memory, Recycler View, not sure why this is here,
so
there's nothing to do with
Recycler
US.
View, to me, represents a kind of a shift in the pattern of how we were developing the framework and the platform, where previously we had support library out there. It started with, I think, the fragment stuff that Diane added early on, and then we had this app compat layer to allow you to use single APIs across versions, but it was really there for just sort of that compat layer stuff. Recycler View was the first time where we said, okay, this is an important utility. We want everybody to use this instead of list view, but instead of putting that API in the platform, we're going to put it in the support library instead. So this was the first step toward what we now call Jetpack, which was this is the first tier of the APIs that developers should use because they work across versions in Android.
Then we introduced Material Design, which was a complete overhaul of the visual look and feel of the platform. But more than that, it was a design system. So we had specs that you could follow, so that you knew exactly how to implement your application. It was a lot more difficult before Material Design to build a good Android application in terms of visuals. Runtime permission, we'll talk about this in more detail in a little bit. Multi-window, Arc++, just a number. And finally, like the last big change we've done to the platform is treble. So over the years, we've always made like sweeping, like large changes under the hood, which sometimes can be very difficult to make those big changes to the implementation without touching the APIs. And treble is one of them. The idea with treble is to add abstractions at a very low level, so that the operating system can be updated without necessarily having to update the drivers for the phone. So this should lead to phones getting updates for longer than they used to, because very often updating the phones meant that the OEMs need to get drivers from the vendors, and either they couldn't because the vendors didn't exist anymore, or they didn't have the resources. So this is one of the ways that we're trying to address fragmentation.
Right, so Project Butter, we mentioned it briefly. This is about us taking a big step back in Jelly Bean and say, okay, now we need to polish. We put all this functionality in, but there are some janky experiences, sort of hiccups in animations and discontinuous behavior that is sort of a bummer for the user. So what can we do to improve that? So we looked at overall performance in many areas. We optimized, I mean, we're optimizing all the time anyway, but sort of from a higher level view, we took like high-speed cameras and said, okay, what happens between person pressing on screen and visuals actually showing up, and what are all the elements that are contributing to that. So we decreased input latency with some clever tricks and sort of figuring out, okay, when there's a motion here, maybe we can project where that motion is going to end up so that we can, you know, guess where the animation or the input will be at that given time in the future. We played with triple and double buffering to decrease latency for stuff showing up on the screen, and we work with a choreographer. This is the first time when we synchronize, okay, when is the display hardware ready to display things, and that's the time when we need to actually trigger things like input processing and animations so that everything in the system, all of that input, all of that animation, all of the re-rendering of the display can all happen in sync, 60 frames a second. We also did a bunch of other performance stuff ever since then. So Art came online in KitKat and became the default runtime in Lollipop, and they've been improving performance basically every release since then. So speeding up the compiler, rewriting stuff in assembly codes, optimizations for allocations and collections. So now we no longer need these workarounds in the APIs before, where, you know, couldn't create a temporary object because it was just going to trigger a painful collection sometime in the future. Now you can kind of do that stuff and not really worry about it. So all of that stuff basically continues and will continue today. In the latest release, they have young generation collections, so temporary object creation and allocation collection is way faster. Don't need to worry about that anymore.
And if you want to know more about all those different optimizations and why Art is so much better than Dalvik, we gave a talk last year somewhere called Trash Talk.
Sure. Yeah.
So look it up. It's probably on YouTube, and we go into a lot of details about, you know, what it means for your application.
We're always working on performance, especially in the framework and the toolkits teams. So hardware bitmap is one of the recent versions of this, where typically if you work with bitmaps, it's a software thing that works in the CPU memory, but we need to get it to the GPU to display it on the screen. So you work with a bitmap, then it transfers to a texture. We have the ability to have shared memory, so you can just work with this one thing. Not only saves on memory, but also saves on upload time. Many other examples, but I just put that one there. And we just continue to work on performance. In fact, one of the things that's happened in your team recently was the benchmarking library to give us a way to actually test performance of things like the Android X library, and then expose that as APIs so that all of you can more easily work on performance as well.
Design, we mentioned it briefly. So we started with Holo for our tablets. Until now, you know, we had a single design for the platform, but it was not very consistent across our application. So it was the first time we tried to have this very solid foundation, again, for the look and feel. Holo was an interesting attempt. It was very blue with a lot of glows.
It was our blue period.
Yeah. It wasn't very good. And then Holo, when it reached phones, it changed and actually looked a lot like Material Design. So then finally in Lollipop, Material Design was the final evolution of Holo. It had a lot of very interesting features, like, you know, all those shadows, the elevation, more animations all over the place, and more importantly, everything was consistent across our application and our system UI. We offer patterns that you can follow. It also started the Material Design component suite of widgets. So there are more widgets than the ones that are in the platform, and more are added regularly by the Material Design team.
All right, so all of that work kind of caught up to where we needed things to be, both in terms of functionality and features and performance and polish. Now we have this sort of professional real platform, so where do we go from there? So there's sort of two areas that we've been focusing on for the past couple of releases that I anticipate we will continue focusing on for the foreseeable future.
And one way I like to think about this is, you know, I mentioned earlier that we had to build all those foundations, and it took us many years. And it's only recently, about, you know, 2-3 years ago, that we finally could stop looking inward, like, and just worry about our own OS, and we could finally start worrying more about you or about the users. So this is what the rest of the presentation is about. So first up,
creepy picture. Creepier picture. All right, so the first one is focus on the developer. It was clear that there's a lot of functionality in Android, but the more we talked to developers, the more we realized it's not necessarily easy to program to. It's not necessarily easy to create a really good-looking, usable application. So what can we do to actually make that easier. So we had discussions with developers, just like you, about what we could do to make the platform easier, or eventually to make Jetpack easier for you to program to create these applications. So a lot of these ideas resulted in something in Jetpack called architecture components, where we said, okay, what are the big pain points of Android? Turns out life cycles are really tricky. I wish we had that diagram here that shows the life cycle of Android, which if you study the entire thing and understand how it all works, you still don't actually know how it works, because it's actually more complicated than that. And then you throw fragments in and your brain explodes, right? So we're introducing APIs and approaches here and patterns to follow that make this a lot easier than it is with the core platform APIs. We introduced local persistent storage with the room stuff, job scheduling with Work Manager in a consistent single API way, instead of you needing the multiple ways of using platform and Google Play services and all that.
And a very important one for us is this this line right here: opinionated guide to development. So this is based on feedback we receive from a lot of developers. A lot of people would like to know how to build their applications, and until fairly recently, basically what we would tell people is like, do whatever you want. Like, we build an OS, we don't know how to build apps. You should do what's best for you, which I still believe is kind of the right thing to say. But rightly so, a lot of developers don't know what is the best thing to do. They don't know what they want. So they just want a solution that is known to work. So this is what we provide through our documentation, through Code Labs, and through some of our libraries. But this is just a way you can build an application. What we provide is not the only way. So if you disagree with some of our patterns or some of our APIs, feel free to not use them. That is completely okay. We just build them so that if you don't care or don't know, we're going to guarantee you a hopefully decent experience as you build your application.
If you would like to have a discussion or argument about why MVVM is not right for you and you think it's the wrong architecture, it's going to be a very short discussion. Our answer is, that's fine. You can do whatever you want.
Actually, it's going to be even shorter than that. Chet, what is MVVM?
It stands for MVVM. All right. We also introduced Kotlin as a supported language. We had interesting discussions with developers where we said, okay, well, would it help you in Android development for us to introduce a new language? And everyone said, no way. Don't confuse things. We have a language that works right now. Stop doing that.
So that's why we did it anyway.
Yeah. And then they said, oh, Kotlin. No, Kotlin. Yeah, we like Kotlin. Go ahead and do the Kotlin thing. In fact, a lot of people were using it already. The only problem was we kept breaking Android Studio with every release because we weren't actually supporting and paying attention to the changes. So we started doing that. We also developed the Kotlin extensions, improved the APIs through the extension mechanism of Kotlin. Coroutines are in there now as an approved pattern, especially now that they're actually stable in the language. For doing asynchronous work. Kotlin Everywhere was a series of events that we were running with JetBrains this year to help train people on just getting up to speed on Kotlin or new capabilities of Kotlin. Let's get everybody on the same page there. And then Jetpack, as I mentioned, is sort of, it wasn't a new thing, it was rather a bundling of a bunch of the things that we'd been doing already. We had the app compat stuff, we have sort of core support library stuff, we had the architecture components, and we wrapped it all up to make it a little less confusing what all of these things were and how they work together.
And our most recent large project to try to make Android development easier is Jetpack Compose. How many of you know about Jetpack Compose or have tried it? Okay, some of you should really watch our presentations and talks. So if you want to know more about Jetpack Compose, we just had the Android Developer Summit in October, and there's a couple of introduction talks. Basically, it's our new UI toolkit, and it's written entirely in Kotlin, which shows the direction we're taking for the future of development on the platform.
So that was the developer. So what are we doing about the user? In particular, what are we doing to make the platform more usable for all of the billions of users across the planet, which affect the way that we need to develop our applications? So we took a look at some of the behaviors that the phone allowed that we really needed to change to make it better for actual real people. And we wanted to talk through 3 of these areas that specifically affect how it is you need to write your applications for these changes.
So this is basically the part of the talk where we remind you of all the things that you don't like about Android development recently. So there are 3 categories of those different changes that we've made over the past few years: so battery, privacy, and usability. Battery, this is obviously a complaint we all have. We all want our phones to last as long as possible. And the Android platform is extremely powerful and lets you do a lot of things that are fantastic for your application and can be fantastic for the user at the moment. But when you combine it with all the other apps installed on the system, it becomes extremely difficult for the system to preserve battery life. So we've taken a number of measures, mostly restrictions, to try to improve battery life overall. Privacy, that one's pretty self-explanatory. We all care about our own personal data and we don't want to expose it unnecessarily. So again, a lot of restrictions and improvements that we've been making to make sure that we can safeguard your data.
Not just safeguard, but also make it transparent what's happening to your data, because it wasn't clear to the user from the way that it bubbled up through permissions or what applications.
We're going to mention a couple of examples. And finally, usability is just about the overall user experience of the phone, making it more pleasant to use. So first, we started in M, Marshmallow, with the feature called Doze. So in Doze mode, when we're trying to basically batch up all the work that should be happening in the background, and we wait for a time when the device is effectively idle. So if the device is unplugged, the screen is off, and very importantly, the device is stationary, then when it goes to sleep mode, that's when we start doing some of the work. You can see here's an example of graph. As you're actively using the device, a bunch of things are happening. Then you go into this Doze mode, we stop doing everything, and we start batching the work across time. Because the fact is, on the phone, some of the most expensive things we can do is waking up the CPUs or waking up the network. So if we don't batch things, every time an application needs to do something, for instance, once a minute, we'll never let the CPU and the network go to sleep, and we'll never be able to save that battery.
App standby, this is about making sure that applications can't do too much in the background. I installed some reading app years ago. I never actually used the thing, but every time I looked at Logcat, I could see it spewing tons of logs, doing something, checking the server, see what books are out there that I hadn't read yet, even though I hadn't read anything. Why was it running all of the time, right? If it's running in the background, if I never use the application, why can't we crank back on what it's doing and preserve the battery for the user, for the things that the user actually wants instead?
And some of our own Google apps were guilty of that, so it's always good to fix our own stuff. Runtime permissions, so when we first introduced Android, we've always had permissions. Whenever you installed an application from the Play Store or Market back then, you had to agree to all those permissions the app needed. The problem is that you had to agree to all of them at once. It was very difficult to understand what some of them were doing because you had no context. The app could not even try to explain to the user why it needed those permissions, and some of them were a little scary, even though they were actually not that bad. So in M now, we have the concept of runtime permissions, where you can request permissions only when you need them, and you're also given a chance in your UI to explain to the user why you need that permission. It can be particularly useful. Some apps absolutely need a specific permission to function correctly, so that gives you a chance to do that.
We know that was a really painful change. Honestly, this is how permissions should have worked from the beginning. So we had to institute it eventually. So sorry for the change, but it's a good thing that it's there for the users. One of the important changes with runtime permissions is also giving the user the ability to disable it afterwards. So before, they sort of accepted all the permissions, and that was the reality that they were living in unless they wanted to uninstall the app. Now they can actually disable that permission. So if they disagree that you need the location permission in order to play that cat game, then they can disable it and you need to deal with it in your application.
Then in N, one of the first improvements we made was to improve Doze. We called it Doze++. The main difference with the previous Doze mode is that the device did not need to be stationary. So before in M, like I said, it had to be stationary, so it worked if you left the device on your bedside table or on your desk, which a lot of people don't necessarily do during the day, so it was not that helpful throughout the day. One of the big changes here is that the device could just be in your pocket. Even as you're moving around, we would still go into Doze mode.
We disabled a bunch of broadcasts, so we had some really interesting behavior where you could listen to events like if the user took a picture or snapped a video, then you could listen for this event and you could wake up and say, oh, do I care about this? So applications did that throughout the device, right? So user snaps a picture and every application on the device wakes up just to see whether it's relevant to them, and it wasn't. But in the meantime, they've thrashed the system entirely because you can't launch all the applications without affecting performance.
And as we did that, we found interesting examples. For instance, Google Maps would wake up when you took a picture, because in Google Maps you can post a picture as a review of a restaurant, for instance, or a place. So they might need to know about pictures. Most users will probably never do that, and yet every time you took a picture, Maps would wake up just in case that's what you wanted to do.
And Maps is pretty heavyweight, so it probably killed all the other apps in the background while I was waking up.
And my favorite example was connectivity broadcast. So this one is a broadcast that's sent every time the phone changes network. So it can be between Wi-Fi and mobile data. It could also be between 2G network and a 3G network, or 3G and 4G, whatever. So I remember I was biking around where I live. You know, there's a bunch of hills, so there's poor connectivity. And so my phone was constantly losing and finding the signal again. And every time it happened, because I was wearing an Android smartwatch, the phone would send a broadcast to all the apps on the phone who happen to have a Wear OS component, because for some reason Wear OS apps need to know about that. So it would wake up all the apps on my phone. There would not be enough memory on the phone to keep all the apps running, so they would kill each other, so they would restart each other, and then in the logs you could see in the span of like a couple minutes, a couple hundred processes were being created and killed. Which meant that even your music that was supposed to run in the background, it's one of the things that always works on Android, was getting killed because we were just hammering the memory of the device and nothing could stay alive. So that was a pretty horrible user experience because of this kind of broadcast.
We also, on the privacy side, limited directory and file sharing, so it was possible as an application to store your file somewhere outside the application-specific area, and then it would just kind of be around for other applications to access.
So this is one of those examples where, as a user, you might not be aware that the application is exposing some of your data through a public channel that is external storage, and you had no control over that. So an app might be writing some of your personal data to that external storage, and another app might be snooping on that personal data, and you would never know.
In the O release, we had some battery improvements like wake clock. So we mentioned this one before. Really important for the phone to have this capability, but there were these situations where an application would grab a wake clock and then they would go in the background and they would keep the wake clock, and we wouldn't get the wake clock back. So the phone couldn't actually go into a deep sleep mode. So now when that app goes into the background, it's basically on a queue somewhere waiting to be killed if the system needs memory. We grab the wake clock back. There's no reason that the app should need it at that point, and it really helps save battery. It is not as easy to just register for interest in a bunch of implicit broadcasts just in case you want those things, so you need to request these things at runtime instead, sort of more actively looking for these capabilities. We have background app limits, such as you can't be in the background and create a background service. And you also can't get location updates as frequently. This tends to just be another memory hog or battery hog that we didn't want to enable anymore.
We also introduced this concept called the Android ID. So many apps need to identify the user, and over the years, apps tended to use, for instance, the IMEI, which is effectively the serial number of the phone, which is a bad idea for a number of reasons. So Android ID was one of the solutions that we came up with. The main benefit of Android ID is that it's something that can be reset. Because the problem, for instance, if your application uses a non-resettable ID, like the IMEI, if I use your app on my phone, and then I give my phone to someone else on my family, or I sell the phone back, or I do a trade-in, when the new Pixel phone comes out, then suddenly my data could be served to a new user, because that new user would be identified with an ID that is not mine anymore. So that you could end up leaking your personal data without even knowing it once again. So it's very important for us to give you, one of those IDs where you can reset it. When you factory reset the phone, like that ID goes away, and the application will never be able to send your data to someone else unless they do something really, really wrong.
So Wi-Fi scanning, this is the first of many changes that we've made in the last few releases, where there are so many ways to get the user's location on the phone. All these backdoors, like there's obviously the location permission, you can ask the location APIs, but you can also do things like find out what Wi-Fi router they're connected to, and then use databases that are available in the world to say, okay, how do I link that to location? This is not what the user had in mind when they gave you the ability to access the network. So now, if you have the permission to do Wi-Fi scanning, you also need permission to look up location, because that is a backdoor into that information. On the P release, on the battery side, so we came up with this idea of app standby buckets to see sort of what state the application was in, and therefore what capabilities they actually needed to use that would use the battery. So if you're active, if it's the foreground application, knock yourself out. You have access. The user is using your app. I think it's okay to actually use the facilities on the platform. If you're in the working set, so they're not using it, but maybe they run this thing every day, then, okay, well, when you're in the background, you can't do other things that maybe don't need to happen in the background. Frequent means, well, they're not running it every day, but they do run it, often enough that you should have some basic capabilities in the background. Rare means, okay, well, they have run it before, but they really don't run it very often, so we're going to continue cranking back on most capabilities. And then what about that reading app that I installed? I never actually ran the thing. Well, maybe it shouldn't be doing anything at all, because that's not what the user wants.
So the battery saver feature, I don't remember when we introduced it, but a long time ago we introduced that feature where you can go in settings, you can turn on the battery saver mode, and basically originally what it was doing was turn off animations because animation uses a ton of CPU and GPU.
We should have just called it "Give me a horrible user experience."
Yeah, which also apparently broke a bunch of apps because it doesn't trigger the animation ended listeners, which if you rely on that, then you're in trouble. Anyway, so it turns out that running those animations was not using that much battery, so we stopped doing that. So now the battery saver keeps the animations, but instead we do other things to save battery. So for instance, location may be disabled as soon as you turn the screen off, or background apps will have no network to ensure that they don't suck up that juice just to contact their servers while in the background. We also introduced restrictions on Wi-Fi scanning. When you're in the foreground, you can only scan 4 times every couple minutes or something like that. And when you're in the background, you can only do it once every 30 minutes. The problem is that some apps were constantly scanning for new Wi-Fi networks. And when you do that, the client kind of has to stop all the traffic on the local Wi-Fi adapter, which means that if you're trying to watch a YouTube video or doing a download, that will be interrupted by that app that was constantly scanning the Wi-Fi. So if you've ever found that network seemed stuck on your phone, maybe that's what was going on.
On the privacy side, here's another backdoor to location information. If you can get, again, information about the Wi-Fi network, then you can also get location. So now we require that location permission. Also in the P release, for privacy, background sensor access, it's not possible now to access the microphone or the camera while you're running in the background. Seems
so
reasonable.
That was about privacy, but we've also seen apps in the past that would just, start opening the microphone just so that the OS would not kill the app. That is not the right way to keep your app running. Please don't do that.
Not a sound approach. All right, new call log permission. You could get the phone permission previously and get information about the call log. The user needs to know that you actually are accessing the call log, not just the phone itself. So we made a more explicit permission that you need to get, and then you need the read call log if you want permission to actually read the information there. Cell info requires location services. Again, there's APIs that sort of have a background way of getting location information.
And you can see a pattern here. Some apps really, really, really want your location, so they kept finding new ways of getting to that location, and we keep taking that away.
All right, on the usability side, this is the first time that we attack something, they call it non-SDK interfaces. We all know it as fixing the private API problem. So we have these APIs in the platform that maybe they're marked @hide, which means they don't show up in the SDK, but they're actually there as public methods, or maybe they're just private methods, but basically they're implementation details that the platform, the framework teams use to make things work. And then in the next release, they may change things, change parameters, change the name of the method, remove it entirely, whatever. Doesn't matter because it's not public API. But meanwhile, an application out there has said, oh, this is an easier way for me to do this thing that I wanted to do, so I'm just going to use reflection, call into that method, and then the new release comes out and application crashes, right? So we change APIs that we never intended to be public, but applications are using them anyway.
And so there were a couple of things we were trying to fix. First, for instance, a new version of Android might change the API, or an OEM might change, the source code of Android. If it's not part of the public API, there's no reason why they cannot change it, which could lead to some apps crashing, which leads to bad user experience. So we wanted to address that. The other thing was sometimes it was hard for us working on the platform to fix some things because there were popular applications using those private APIs, and I know there's at least a couple bugs I can remember that we never fixed because they were part of private APIs, and there's a big app out there using them, and so we cannot touch it, which makes it very difficult for us to evolve the platform and to improve the platform. There was something else about private APIs that I wanted to mention. I forgot.
But in the meantime, so what we really want to do, the reason this is in the usability area is, wouldn't it be nice if we stopped crashing applications for the user, right? They upgrade their phone and all of a sudden their favorite game doesn't run anymore because we've changed an API that we didn't know people were using.
Oh yeah, remember, so the way we went about it, we looked at Play Store, we looked at all the calls that all the apps are making, and we had a giant list of all the private APIs that were used by the apps, and we went through them one by one to decide, should this be whitelisted, and you can call that private API? Is there an existing public alternative that the app should be using? Then we keep that private API private, and if you call it, it breaks the app. Or is it an API that we really, really don't want you to call, and we're not going to make a public alternative, and we're going to put it in a blacklist? There are only very few APIs that I think we put in that blacklist, and we in every version of Android, we keep looking at the list to make sure that we're doing the right thing. So we're trying to help you as much as possible to some extent. The surprising thing was that there was a bunch of public APIs that have been public since Android 1, and yet applications were accessing them through private means, which doesn't make much sense to me.
They're just being too clever.
Yes.
All right, so on to Q. On the battery side, turns out if the user doesn't want to enable Wi-Fi, maybe the application shouldn't do it anyway. But sometimes applications do need to enable Wi-Fi or need the user to enable Wi-Fi. And it can be problematic to, in your application, say, oh, please go to settings, and I don't know what it looks like on your particular device, but somehow find the Wi-Fi settings and enable that, and then please come back to this application. That's really problematic, so we introduced a new API and a new UI where you can launch this inline in your application and say, I really need you to enable Wi-Fi on behalf of this application, so here's a UI where you can do that, and then you're basically toggling the global settings on the phone, but you're doing it inline with the app so they're not going out of the app and then having to come back. On the privacy side, scope storage. So now, by default, applications can only access the files that they created in external storage. You can also get access to audio, video, images through APIs using the proper permissions, and you cannot get access to arbitrary files unless you use the storage access framework, which basically brings up the system file picker. Remember, it's about giving the user information about what's going on. So if you need access to a PDF file, they need to know that you're getting that, so they need to be involved in that.
So that one is interesting. When you access a photo, now we remove the metadata, so basically what's in the EXIF segment of a photo. And the reason is the photo might contain your location, which means that an app could be looking at your photos to track your location without asking for the location permission. There is a way to access the location of photos, but this is a specific permission that the app has to request and the user has to accept.
Speaking of location, are you picking up a theme about location? All these different ways of getting this information. So now there's a tri-state for location where the app can grant the permission while the app is in the foreground, or they can deny it entirely, or they can either accept or deny when the app is in the background. So you can explain to the user what you need, and then they can make the right choice for their situation. On the privacy side, so even if you get access to contacts, the proper permissions, you can't find out the recency, how often they contact each person, so we removed that. ProcNet was yet another way that you could access location. You get information about the networks in this sort of temporary utility directory somewhere in the system, and then you could sort of connect the dots and find location information from that. We also moved further in resettable IDs, so we did Android ID before, recommended that people use that. Now we're also recommending that people use as advertising ID. Again, it's about disabling the ability to have these non-resettable IDs accessed on the device. And clipboard data, you should really only have access to this if you're the foreground application or the keyboard. There's no reason why anybody running in the background should have access to that information.
So camera metadata is information about the camera hardware itself. Now it requires the camera permission, and it's because accessing that kind of information could be used as a way to identify your device and therefore you as you do several different things on the network. And again, if you use any kind of network capability of the phone, now you need to the permission access find location, because all those are ways for the application to identify your location.
And user improvements. So we did more private API stuff, added to all of those lists, and this is going to be an ongoing change in the next several releases because there are thousands of these methods that we need to fix. And
we do listen, so if there are private APIs that you use in your application and you believe that it should be a public API, please file feature request on b.android.com, or if you look at developer.android.com, we have a page dedicated to this non-SDK interfaces project, and we explain how you can request the private API to become a public API. We look at all of them. Sometimes we disagree, but sometimes we agree and we make that a public API.
And one of my favorite changes was disabling the ability for a background app to start an activity. Sometimes this is really important, right? What if you're running in the background, you are the phone application, and you need to actually pop up some sort of phone dialogue in front of the user? Great. But what if you want to pop up a full screen ad in front of the user instead? So there's a couple of examples, like what if you're actually navigating using maps, and then an ad launches in the foreground, and all of a sudden your nice little navigation API became a little picture-in-picture, and you have to try to figure out what's going on there. Kind of a horrible experience. Not as bad as this one, where somebody was in a ride-sharing car, and they were using their navigation app up there, and this full screen ad kept popping up in front of the map. They didn't know where they were going. They missed their exit, and they're swerving all over the highway just trying to get rid of the full screen ad. So we disabled this capability so you can no longer launch these activities. And in the last week alone, we disabled almost 18 million pop-ups. So hopefully a horrible user experience just went away from the platform.
And it's a good example of, I want to emphasize that we know there are legitimate use cases for this kind of API, but the bad ways to use this API outweigh by far the good ways to use this API. So it was a tough choice, but this is the right choice.
All right, so wrapping it up, we have battery changes, which is all about limiting the battery to the activities that the user actually wants to be doing at the time to preserve that battery for what they need. Privacy, which is about not just protecting the user's data, but also making it more transparent what's actually going on in the system, and just making the behavior of the entire platform more predictable and usable for them.
So all that to say, we know it's painful, but we appreciate your help.
And thank you.